Eighth grade lesson 7.4 is equations with many solutions or infinite solutions or no solutions. And so we'll be solving some equations. Think of these like puzzles. I really am nerdy and enjoy doing these as puzzles and just moving the numbers around. And then what will happen sometimes, we've been finding solutions that have one solution only, but sometimes that doesn't always happen. So this lesson is about what that means when that doesn't always happen. And they start off by talking to us about, they give us this chart. So let me explain this chart a little bit, because at first look with you have x equal a equals a, it's kind of confusing. It does need some explanation. So let me explain it a little bit. So what they mean here, for have equation that has one solution, these are the ones we've been solving all along. They say x equals a. It's when x equals a, and that's a little confusing. When the value of x equals a, the equation is a true statement. Let me put some numbers there to make it make sense. Usually we go and we've been solving these problems, and at the end we isolate the variable, and then we get this answer like x equals 12. Or x equals 9, or x equals 10,000, or something. X equals a number, a single number, one solution. So if you come down to an x equals some number, at 12 or 30 or 24 or whatever, then you have one solution. X is that and that only. So one solution. Sometimes you might come down to, as you calculate through, you end up with something. They say a equals a. What they mean by that, what will show up is you'll get to the end, you will have manipulated everything around, and you end up with 5 equals 5. Or 12 equals 12. And there's no variable or anything. Even if it was x equals x, even if you ended up with that, that means that there's infinitely many possibilities. Like every single spot on a line is the possible answer. So if you end up with an answer that looks like that, then you've got infinitely many solutions. And finally, sometimes you end up with something that's just plain false, and that's this bottom one here. They say, oh, if you get a equals b, that means that there are no solutions. There's nothing that equals that. What they mean by that in numbers, so you can see it in numbers, is if we end up with something like 4 equals 5, well, you and I both know that 4 does not equal 5. That is not equal. That's false. So that would mean no solutions. If I got 12 equals 3, 2 million equals 3, right? Those don't equal each other, and we know those don't equal. It's false. That means there are no solutions to that problem. So if you go through and you solve, and one of those things happens, now you can know what they mean. You'll want to have this chart that they gave us on that page handy. You have access to the notes that I created for you. That's the very first part of the notes, and it has these examples with it, so you can print that off if you think that would be helpful, the first page of the notes. From lesson 7.4, you can print that off and have that handy if you'd like that better. After a while, you start to kind of recognize, oh, okay, this is that. But for a while, you'll need the chart. Let's go ahead and practice a few of these to see what it means. Okay, this looks familiar. This is the same sort of thing you were doing in the previous lesson. We get a lot more practice on this. I'll put some steps here for you to help you out. Okay, so in the steps that we've been using, I just have them here just to refresh our memory. We would start by distributing if we needed to, if there were parentheses in here that we need to distribute through, and marry the like terms. There's no distribution and there's no like terms on same side of equation, so I can skip that step in this particular equation. Then I'm going to get my differing terms on opposite sides of the equation. So I've got the 2x over here, positive 2x. I could either remove it from this side and do the same on the other side of the equation, or I have all kinds of choices. I can remove this from this side to get it to this side, you know, so I have tons of choices. I think what I'm going to do is go ahead and take this positive 2x, do the inverse of that to both sides of the equation. That's going to give me a 4 minus 2 is 2x's. I'm still working that through. I like to do one bite at a time and let my brain see what's going on so it doesn't get confused. Now I'm going to take this negative 3, and do the inverse of that to get all the numbers on the same side of the equation. That leaves me with 2x equals 16. And now I'm on to the step to isolate the variable using inverse operations. Here's my variable. It's being multiplied by 2, so I will divide by 2 to both sides of the equation. 16 divided by 2 is 8. Now, back to that chart again. If x equals a number, one specific number, then it has just one solution. And you might have to peek back at that chart from page 217 or have it tabbed or something, or look at your notes. And so we do the same solving of the problem as we've been doing, but now we're identifying, okay, there's only one solution possible for this equation. X is going to come up with one answer and one answer only. Let's look at what happens if it doesn't. Okay, I have my abbreviated steps here. Distribute Mary-like terms. Get your terms on opposite sides of the equation, like terms on opposite sides of the equation, and then isolate the variable using inverse operations. I've got some distribution I need to do over here, so I'm going to take care of that. I'm going to do 2 times the term 2x, and then this positive 2 also times the term negative 1. So this is going to give me 4x, and 2 times negative 1 is negative 2. Everything else I didn't do anything to, so I'm just going to bring everything else down one bite at a time. Okay, one thing is done. Then I'm going to go ahead and marry any like terms on the same side of the equation. These two are not like terms. This is not like these, but these two are like terms. So let's go ahead and put them together right now. A negative 2 put together with a negative 3. I owe 2, then I owe 3 more. That means I owe 5. Bring down everything else so your brain can see the next step. All right, now I've got everything married, distributed and married, so now I'm on step 2. Get your like terms on the same sides of an equation as each other. So I have this 5, I can move over here, or the 4x, I can move over there, or vice versa. Like, I have tons of choices at this stage. I think I'm going to go ahead and take this negative 5, do the inverse to get it over there. So we're going to say add 5 to get rid of it, add 5. And actually that canceled itself out. So, okay, that's fine. That leaves me now with 4x equals 4x. Now to isolate, now I'm isolating the variable. To isolate this variable here, I have to divide by 4. Do the same to both sides of the equation. And that leaves me with x equals, well, that actually equals x. And so that happens sometimes. And so if you look at the chart from page 217 or the notes that I provided to you, when you get that scenario where this one equals the same thing as that one, that means we have infinite many answers, possibilities. They would all lie on the same line. So infinitely many possibilities. So that's the next thing that they're asking. So we've kind of worked on this in the previous lesson, the solving of it. But now we're just looking at, oh, sometimes it doesn't quite work out, x equals something. Sometimes this happens. And so they're just having you identify, wow, we get practice doing this. They're also having us identify what happened. Okay, let's look at one more. Okay, look at my notes, keep getting more and more abbreviated. Distribute and marry if you need to, marry like terms if you need to. Get your like terms on the same sides of the equation as each other. Isolate the variable by using inverse operations. So let's go ahead and do those steps. There's no distribution and there's no like terms on the same side of the equation, so I can skip to step 2. I think to keep things positive, instead of this negative 5, I'm going to undo that. I just like to keep things positive. This will give me 4x still, because I haven't done anything with that, plus 7 equals 4x. And that canceled out, so it's gone. Okay. I want to move this 4x over away from that 7. And that canceled out. 7 is still there. 4x minus 4x is actually, well, it's 0, actually. So I end up with an answer of 7 equals 0. And we all know 7 doesn't equal 0. That's not true. So this would be no solution. And so that's what happens when you see that. It's just no solution. It's false, no solution. So that's what this lesson is all about, plus the practice of handling those equations. I think it turns out so pretty. It's like artwork, all that math going on there. So I like it. Then in the example 2, they say, hey, you write a linear equation in one variable that has no solution. So they kind of give us some strategies and some steps on how to do that, how to write our own. So we would work backwards. So they say start with something that's untrue, like 3 equals 5. That's not true. So we're going to start with that. And then they said add the same variable term to both sides. So let's just put a positive x added to both sides. Then they say add the same constant to both sides and combine the like terms on each side of the equation. So we're going to add the same constant to both sides. And they added 7 to both sides. So we'll add 7 to both sides of the equation. And of course, that's going to like term with these constants there. So x plus 10 equals 12 plus x, and because we added them to the same number to both sides, like we're not changing anything from our original 3 equals 5, as long as we're doing the same thing to both sides, right? Then we would verify that our equation has no solution by using properties of equality to simplify it. So then we'd work backwards and simplify it with the steps like we normally do, just to make sure we did it right. I would go negative 10, negative 10. That's going to cancel. I get 2 plus x. Subtract x from both sides of the equation. 0 equals 2. And no, it doesn't. No solution. So that would be how you could find, you can write your own problem that has no solution. Why would they ask us to do that? Probably the reasoning in my mind is that helps you kind of keep an eye out for what you might, for the deeper understanding of it. Because what you'll find as you get in deeper understanding of this, you'll get partway through and be like, oh, I know where this is going. I know this is going to be a no solution. Or I know where this is going. This is going to be inverse. Because you start seeing it play out. And so if you work things backwards sometimes, it helps you see that. So these are the steps of how to write your own no solution problem. We started with a false statement. And then we added x to both sides, same thing to both sides. And then we added 7 to both sides, same thing to both sides. So it kept it false all the way through. So that's how you do that if they ask you to write one of your own. Otherwise, that's it. That's the lesson. It just takes time and practice, and you guys are coming along nicely on that anyway. So good luck on that. Let me know if you need me.